Hey everyone, so we're going to be jumping into 3.2 now, which is the Pythonic lecture. So it's the Pythonic lecture, which sounds like a funny topic. Um, but basically, this lecture is about writing good Python code. So how do you write good Python code? And generally, what is considered good Python code, we use the word Pythonic to describe it as. So firstly, what in God's name is a strange word that sounds like someone just made it up because it sounds cool. So being Pythonic doesn't mean that you're like... what is good style? Good style is commenting your code and, using the right variable names. But being Pythonic kind of takes that a step above, and it's where your code generally follows a set of idioms or, guidelines, if you will, that are agreed upon by the broader Python community. So the Python community, if you imagine this as just some abstract collection of, cool nerds who are just hanging around, loving Python, making sure everyone's writing great Python, and you imagine them sitting down in a giant room every year and thinking about, okay, what's good Python code and what's bad Python code? And it generally boils down to a series of rules and principles. And you can see here it says, when a veteran Python developer calls portions of code not Pythonic, it usually means that they don't follow these common guidelines. And there's a whole bit more you can read on this if you want. There's there's a lot to it, right? Like Pythonic is a very broad topic that we can only just touch on. But generally it's just following principles. And in this lecture, we're going to talk about doc strings, MapReduce filter, exceptions, destructuring enumerations, multi-line strings, just like some of these, but there are a lot more than what we have here, right? These are just some of the ones that are relevant. So firstly, doc strings. Doc strings are a standard way to document your code and make it clear to other programmers what the intent and meaning is behind what you're trying to say. And it generally consists of three parts, which is the description of what your function does, generally, the parameters, and the return, like what it gives back. So there's like 0 or more parameters. There's usually 0 or 1 return type, either it's nothing or it's something. And then there's a description of it. And you put this usually just under the function definition line where you specify the parameters, and you do this comment with the block string, right? Like the three double apostrophes like that. So, in a piece of code, it looks pretty simple. It just kind of looks like this. You're like, okay, so if I have a function called string find, and I go and do stuff here, like, for C in haystack, if C equals needle, return true. Like, this is the kind of thing you might do. There is a Python docstring generator extension in VS Code. There's usually a VS Code extension for everything. But that's really it. And this is like kind of the standard Pythonic way to document your functions. Like, obviously you could just put in some comments above this and be like, blah, 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 blur, blah, like that. Though, while this is good style in the sense that you are commenting your code and following the generally accepted style practices, it's not really Pythonic because it's not following the kind of common guidelines that the community would follow. So that's docstring documentation. That one's pretty simple. Another series of functions are MapReduce and filter functions. These ones are super useful. We're not going to talk about reduce. You can look that up in your own time if you want, but we will talk about the map and filter functions. So I'll give you an example of the filter function. Let me just quickly... I actually think we have one, sorry. Derp. So, and by the way, we're talking about a lot of like random things here, and like some of it requires you to go and read more. So trying to keep it like pretty straightforward. The two things that matter to us here are map and filter. We're not going to talk about reduce. Now, the way map works, right, is a map function in Python is given a list of, say, 10 elements. And what it does is it applies a function to every element in that list and produces a different list that also contains 10 elements. So what a map function does is it takes a list of length n, it outputs a list of length n, but all of the values in the list have changed. And a filter function, by comparison, takes in a list of size n, it outputs a list of a different size, less than n, but it doesn't modify the variables. Okay, so let's look at filter first, because I think filter's pretty straightforward. If we have a list of marks like this, right, so this is a very straightforward Python program. We have if name equals main, then we create a list of marks, right, 65, 72, 81, 40. If I said to you, can you go and get me the average passing mark, as in the average mark of students who pass the course, you might do something like this. You might say, well, new marks is an empty list, and then for mark in marks, if mark is greater than 50, greater or equal to 50, new marks dot append mark. And then I might use the Python average function or something. Is there an average? Oh, there's not. Let's say, total. Yeah, sure. Print sum of new marks divided by length of new marks, right? So the average. And we could run that program, python3 filter.py, and we get 68.5. That's how you might just intuitively do it if I gave that to you as a lab exercise, right? You would just loop through it and do whatever. What you're actually doing here, though, is what we call a filter function, which is you're taking a list, you're trying to find a sublist of it according to a rule, and you're not trying to modify the elements. You're just trying to filter it. You're trying to get certain types out. So we can actually do this in one line a little easier by doing something like this. By doing something like this instead. So I'm just going to comment this out. And what we do here is we say, it's a little bit weird, I'm not going to lie, is we say that I'm going to filter through the marks list according to this function. So this is the part you need to focus on right now, the highlighted part. And what a filter function does is it takes in a rule and it takes in a list. It applies that rule to every element in a list, and then it gives you a smaller list. Now this lambda stuff here is a little bit weird. Basically, this exists in a few languages, and I really don't like Python's, just like how they do lambdas, but basically lambdas are like ways of defining mini functions, right? So see this little lambda thing here I've highlighted. I could make my own little mini function above this by going def pass mark if mark is greater or equal to 50, return true, else return false, right? So these simple Python functions, right, that are just kind of like basically running a condition and then returning true or false. Sometimes we write them in this shorthand version, which is kind of like this. So see how I've got m here? If I was to change this, for instance, to m, you can actually see how they're quite similar. This function up here is a function that takes in a variable called m. It applies a condition to it, and then it returns true or false depending on what that condition is. And here we're doing the same thing. We're saying, yep, we've got this lambda, which is like a mini function, where it takes in a parameter called m as an argument, and then it applies this rule, like this is the check that it does, and this is either going to return true or false. So this, again, mini function. I'm pretty sure we could also put in something like this too, I think. I forgot my colons. Yeah, so this also works, which might be a way to help people understand it, which is filter takes in a rule as a function. So it takes in a function that describes a rule, and it takes in a list. It applies that rule to every element in the list, and then it craps out a smaller list, a filtered list. Except rather than have to go and define this whole function up here, we can use smaller syntax, which is kind of like this. Now, you don't have to use lambdas. They're absolutely avoidable in pretty much everything you do. So if this kind of confuses you and my explanation doesn't make sense and you don't want to spend time like reading into it, you can actually just use normal functions like this, though it would then become questionable as to how much space this actually saves you. But the point is, these kinds of simple filters here are generally considered to be Pythonic because of how small they are. You can write really simple programs like this. See, we've got our marks list, we get our new marks, which is a filter of the original list, and then we print out the average of it. A lambda is a function. I don't know if I'd call it an object, but it is a function. Lambda is a function. Praf says, so the filter just gets rid of like for I in marks. Yeah, it's an easier way to essentially do that original piece of code we wrote. And it's just because like it's such a simple thing. It's like, I just want to filter this list. It does create a new list, right? It doesn't delete things from the list, just to be clear. It actually creates a new list. So marks is still preserved here. Filter creates a new list. If I print marks, I get the original list. Trent says, why do we need list filter? What does filter return by default? That's a great question, Mark. We can find that out too. So if you try and actually see what filter returns by default, it actually returns you a weird type, which is an object, like a filter object, which is just like a weird concept that we don't really want to go into. So basically, if you wrap your filtered result in list, it turns it back into a list for you. It's a little bit like casting it like an int or a string. So you know that can be really helpful. William says, what would new marks equals filter lambda? Oh, I think I just showed that. So this done iteration and append at the same time. Correct, yes. It did all of that. It did what we had before. This line here, this new marks line, does the exact same thing as new marks equals this, and for mark in marks, if mark is greater or equal to 50, new marks dot append. It's all the same stuff. So it's much simpler. The second function that's interesting is map. What map does is map doesn't change the size of the list, right? What it does is map actually modifies the items in the list. And to give you an example of that, let's say that I wanted to do this, right? I'll do let's get rid of this new mark stuff for a second. We can do something else. This will be our map example. Now I want to say that info marks is another list. And I'm going to say for mark in marks, right? So we're going to loop through every single element here. I'm going to say info marks.append. But instead of this being a list of numbers, I'm going to make it a list of dictionaries. And each dictionary here is going to actually let me do this a better way. What I'd like to do is when I append to info marks, if the mark is less than 50, i.e. it's a fail, I'd like to just append fail the string. And if the mark's greater than 50, I just want to append the mark. Basically, I'm trying to hide the actual marks of students less than 50. Kind of like with your ATAR, how they just say less than 30, even though you actually have a really bad ATAR if it's less than 30. They just say less than 30, right? So we can do something like this, where it's like, okay, if someone has less than 50, we just say fail. This that we're doing here is what we would call a mapping exercise, whereby we are taking a list of size n, we are outputting a list of size n, but we are applying a rule to each element that kind of modifies it, right? We're mapping it. Does that make sense? So like if I was to print out marks here, it's kind of like saying we're mapping 65 to 65, 72 to 72, 81 to 81, 40 to fail, and 56 to 56. You can actually do the same thing here with like marks, like HD, D, credit if you wanted to. I'm keeping it fairly simple. But we can actually use the map, the map function here. Let's do a similar thing to what we did with filter, where we'll make a function first before we worry about lambdas called mark map, which takes in a mark. And if the mark is less than 50, we're going to return fail. And if the mark is greater than 50 or equal to 50, we return mark, or m. Right? So that's the rule function. That's the thing we're going to apply to every element. So now instead of having to do all this code here, which is kind of lengthy, we can do something more Pythonic, where we say, I'm just going to get rid of these stupid tabs because they're hurting me. We would say info marks equals list map. And then what do our map and filter functions take in? They take in a rule or a function, and then they take in a list. So here with map, I say I'm going to pass it in mark map, and then I'm going to give it my marks. So it takes the function, takes the list. Let's see how this goes. Okay, this also seems to work, right? So really simple. The map function goes through every element in marks, and it applies the function to it to produce a new list of the same size. I could make this even simpler though by writing this as a lambda. So everything up to this point with map we expect you to use. The use of lambdas though might confuse some of you, so we're okay if you don't want to use them. But lambdas are actually very straightforward, and I'll show you. Let me convert this function here to a lambda in real time, and then you can see how the relationship is. So the first thing is lambdas don't have the def or the function name. I just say lambda like that. The next thing is we need a way to kind of reduce this logic here to one line. Actually, let me do that part first. That might be easier. Let's reduce this logic to one line. So instead of saying if m is less than 50, return fail, else return m, I could cut out that else, like this. Then I could also simplify it by instead saying return fail if m is less than 50, else m. So this is one of the shorthand ways in Python to write if statements in like a ternary format, by saying like return fail if m is less than. It's a bit weird, but it's just like it works. It's literally just this. Generally, we like these kinds of shorthand returns in Python if all your if-else statement is doing is returning two different things. So that's the use case for it, right? If condition, return A, else return B. If you're in that kind of scenario, then you tend to use these kinds of if statements. So we have this simple one here. And now to convert this to a lambda, it's really simple. All I'm going to do is replace this top line here with lambda m. And then I'm going to get rid of the return. And that's my lambda right there. And it's even simpler. So now we've managed to reduce it down quite aggressively. Perhaps says to map as something like pop and insert with a condition. Oh, I don't want to call it pop and insert because pop actually removes it from a list. It's more like just go through every element of the old list and put a new element in the new list, according to a rule. Tenet says, I feel like lambda function is like a function that we did not care about its name. That's kind of literally it. It's a shorthand way to write a function without giving it a name, which is kind of handy. Fangyu says, if we create two short functions and using lambda to represent, how are we going to distinguish them? That's a great question, Fangyu. And the answer is that with lambda functions, you tend to make them a lambda if you're only using them once. So for instance, if I was doing this a couple of times for some reason, I would usually separate the lambda out into a variable or a separate function, but we're not really going to talk about that. But generally it's kind of for simple uses. Great. You can go and read about reduce in your own time. Exceptions over early returns. Yeah, this one we don't need to talk about a ton because essentially, like, this is just kind of encouraging you to use exceptions. So last week we learnt about exceptions, and we learnt about, like, like your C-style brain might be inclined to do something like, if you want to say that something failed, is to return none or return -1 or something like this. That is not very Pythonic. In general, a Pythonic approach is to use exceptions to denote errors. So if something ever goes wrong in a function, you shouldn't notify someone it went wrong by returning a different value. You should notify them it went wrong by throwing an exception and expecting them to catch it. So these two examples here in a slide are that early.py here, if someone asks for a square root of a number less than 0, we return none, right? Which isn't very good, because something's gone wrong, but we're actually just giving them a different value. Whereas what we'd prefer to do is actually raise an exception. We could raise a standard Python exception, we could make our own exception, which is what this one does, but just throwing exception would be absolutely fine here. So exceptions over early returns are another form of Pythonic code. To loop back to two questions that just came up, someone said, so lambda is kind of like using ternary operators in C for conditions. No, well, sort of. It's like ternary operators are a separate thing, but lambdas tend to use them. Lambdas are shorthand ways of writing functions, ternary or not, though usually ternary is a big part of it. Bill says, should we replace the for loop with map and filter if possible? Yeah, so I don't know if it's in iteration 1, but it's definitely in iteration 2 and 3. We tell you that part of your marks will come from how Pythonic your code is. So your tutor will have a look at your code, and if there's elements there that aren't very Pythonic, which includes using map and filter where applicable, then it might be harder to get the same kinds of marks. Destructuring. We talked about destructuring, I think, back in week 1 when we talked about tuples. Destructuring is the process whereby you have a tuple and you break it up into its components, right? So I'm not going to go through the example of this because we've already done it. The point of this slide is to explain that is considered Pythonic and to just give you a second example. As you can see here, this convert function returns a tuple which contains 2 elements, right? The square root of 2 squares and then the degrees. This is like one of those fun things that's converting Cartesian coordinates into polar coordinates for anyone who remembers high school. And as you can see, the function actually returns, the convert function returns a tuple with 2 elements in it. And therefore we can destructure it by pulling those 2 elements out. Like that. And let's play around with it really quick. So destructure example here. If I was to run this, Python 3 destructure, enter x coordinate, maybe 3 and 4. So it says if I have like something like 3x and 4 up, then I have a magnitude of 5 with a degree, 53 degrees from the horizontal, right? So kind of simple conversion there. One thing I didn't mention during the week 1 tuples lecture is that someone asked this question, which was like, what happens if I don't want everything? Like, what happens if I only want the first or the second one? And I think I said to you, you have to get all of them out. And that was kind of a half lie, because in practice, you don't actually need to get them all out. In terms, you don't need to store all of those tuple elements in a variable when you destructure it, but you do still need to tell Python that you're aware of the size of it. So one thing you can actually do is if you're only interested in the magnitude and not the direction, degrees. I don't know why that's I think my brain said degrees. Or maybe it's just direction. You can use the underscore. And by using the underscore here, you're kind of saying to Python, I want you to destructure it, but throw it in the bin. Because without this underscore, it would throw an error. It would throw you the unpack error. Oh, it didn't. Huh, okay. I think I'm going crazy. Maybe I mixed that up with something else. Oh, no, sorry. This is the... All right. No, I am not going crazy. So it's funny. What actually happened here was that when we got rid of the second argument, Python could not tell we're trying to destructure this. It's like, okay, well, you're just telling me that mag2 should be equal to the tuple now. So what it actually did was mag2 is now the whole tuple itself. If I put brackets around it, that's an explicit way of telling Python to destructure it. And now it will throw an error. No, it doesn't care. Never mind. I thought that was the true, but it wasn't. Usually we need the commas. So I think if you just have a comma here, it might do it. Now we're just guessing. Yeah, so the comma's a signal here to Python to say, I'm trying to destructure this. And without that second argument, it's like, yeah, I can't do that because I have two things, but you're only asking to like destructure one of them. Claude says, is this destructuring also required when we return more than one value in a fixture and we want to use those individual return values in other functions that call the fixture? Generally, destructuring is a great idea for tuples. The reason is because it's a lot clearer than saying data 0, data 1. That means nothing. That's like, okay, thanks for that information. So by destructuring it, we're able to actually kind of assign a particular name and meaning to each element in the tuple, which basically just means your program is easier to read. Right? And we tend to do it only with tuples because tuples tend to be mixed bags of variables, or they tend to only have 1 or 2 or 3 variables inside of them. We tend not to do it with lists though. So tuples are what you're mainly interested in destructuring. And then last two, very quickly talk about this enumerate example. And the enumerate example, so in Python, really quick, if you want to get all the tutors, you do something like this, tutor. If you want to go through the old style looping, you say for I in range 0 to length tutors, and then you say print tutors I. Now we know that this for range style loop is cleaner, but the benefit of this older school one is that you get the index. So if you care about the index when you loop, for instance, you want to say like tutor 0 is you know, Matthew, tutor 1 is Vivian, tutor 2 is Ian, you kind of have to use this old school loop, which is just a little bit ugly. So another way to do that is to actually use the enumerate function. So instead of kind of doing something like this, where you're like, oh yeah, I'll just do like I plus 1 tutors plus I, like that, you can actually use the enumerate function, which is just a little bit easier to read. And what the enumerate function does is, we can print this out, right? I'll show you. So if we just above here, if we print out tutors, and then we print out enumerate tutors, wrong example. Let me convert this to a list. You can see that enumerate, funnily enough, is actually a lot like the map function, where it takes a list of size n, and then it outputs a list of size n. It's just that instead of these elements being strings, they're actually tuples of an index and a string. So enumerate's kind of like a map function that adds the index to each element, and then that's really cool, because when you loop through it, you can actually just destructure it, right? Because each element now is not a string, it's actually a tuple. So while you might look at this loop here and think, oh, that's similar to the index loop, this is actually a lot closer to the for range loop, right? Because you can actually see that here. See how it's like for item in list of items? Except here, the list of items is not just the strings, it's the strings and the number as tuples. And then we destructure that each loop. We're saying each time we loop, I want you to extract this tuple here into index and into name. And then the next time we loop, we extract it into index and then into name. And then that's how you can do more interesting things with loops. So enumerate's a very powerful way if you want to have a modern style loop that actually cares about what index you're up to. And that's also considered Pythonic. And then last thing, just because I want to get onto this PyLint lecture, is you can do multi-line strings in Python. And what I mean by multi-line strings is that rather than kind of have to say, like, this is what you might do currently if you want to do a multi-line string. You might do something like this, where you just like kind of like, you know, text2 and you just keep like adding to it. If you want to like keep your code clean, like if you have lots of really long lines. And in this case, what you'll do is multi-line. Yeah, so this actually will like join these together for you. But if you don't want to do that, you can actually just do it like this, which is what we have here. If you just say text2 equals something, and then you just put all the strings with no commas, no anything between them, just the strings on new lines, Python will be able to join those together for you. So that one's very, very simple, that slide. There's not much to that. And then Yuval has asked, does this mean that lists in Python are a global class with enumerate as one of their methods? Not really. Enumerate's a global function. It's a little bit like len and other things. There's some weird functions in Python that are global for reasons I don't fully understand. And just to be clear, yeah, you can usually delete lines in most editors by holding Shift when you press delete. It'll delete the whole line. Great, that pretty much sums up the Pythonic stuff. There's a lot more to this. You don't just have to rely on the things I've mentioned here. Uh-oh. Okay, that was weird. There's a whole article on it. You can read through more of it. But this is a good place to start, that many of you will be able to apply these methods to your own project. So, yeah.